Hi guys, so this is the MIT entrance exam from way back in 1869. So it's mostly algebra and let's see what these problems were like from 1869 for this prestigious school. As you can see, the date here is June 7th, 1869. So let's look at the first one. If e is equal to 8, find the numerical value of the following expression. So I copied it over. Okay, so all we have to do is plug in 8 for e and evaluate. So we have 8 minus square root of 8 plus 1 plus 2 plus 8 minus the cube root of 8 times the square root of 8 minus 4. This is the square root of 9, which is 3, plus 2, plus 8 minus the cube root of 8 is 2, and then the square root of 8 minus 4. That's the square root of 4, which is 2. So this is 8 minus 5 plus, in parentheses first, 8 minus 2 is 6 times 2. So we get 3 plus 12, which is 15. And that's problem number 1. What did you think? Was it easy? Let me know in the comments. So now we have problem number 2. Simplify the following expression by removing the brackets and collecting like terms. This is an expression involving a and b, and I have it here. Okay, so we get 3a minus, let's get rid of the parentheses, b plus 2a minus b. We can distribute the minus sign. We get minus a plus b. Now let's combine like terms. 2a minus a gives us an a. b minus b plus b gives us a b. So we get 3a minus a minus b. 3a minus a is 2a. So we have 2a minus b. So this next one is multiply 3a squared plus ab minus b squared by a squared minus 2ab minus 3b squared, and divide the product by a plus b. So let's write this out. Okay, so let's write this as a fraction. 3a squared plus ab minus b squared times a squared minus 2ab minus 3b squared, and we're going to divide all that by a plus b. So it would help if a plus b went into one of these two polynomials. And let's see if we can make that happen. It seems like this one on the right would be the most likely candidate. So let's see if we can write this trinomial, a squared minus 2ab minus 3b squared, as the product of two binomials, one of which being a plus b. So the only way we can make that work is a times this would have to be a squared. So this term would have to be a, and then b times something would be minus 3b squared. So this would have to be minus 3b. And if you multiply these out using the FOIL method, first, outside, inside, and last, a times a gives us a squared. The outside, a times minus 3b, gives us minus 3ab. The inside gives us ab. And the last gives us b times minus 3b, which is minus 3b squared. And we can see that these two terms combine. Minus 3 plus 1 gives us minus 2ab. So this works out. So these really do factor this way. So we can write this as a plus b times a minus 3b. And that allows us to cancel. So what we're left with is 3a squared plus ab minus b squared times a minus 3b. And we just have a product of polynomials here, so we have a little more to do. We have to multiply this out. So we have So now we're multiplying 3 terms times 2 terms, and we'll end up with 6 terms in our answer. And we first take a and multiply it by each of these 3 terms. So we're basically adding 1 to the power of a in each of them. So we get 3a cubed plus a squared b minus a b squared. And then we do the same thing with minus 3b, and we get minus 3 times 3 minus 9 a squared b minus 3 ab squared and plus 3b cubed. And now we just have to combine like terms. And so this one stays by itself. And let's see, a squared b, we have a 1 minus a 9. So that's a minus 8. ab squared, so we have a negative 1 and a negative 3. So that's a negative 4. And then finally, plus 3b cubed. And that's our answer for that one. So problem number 4, reduce this fraction to lowest term. So let's take a look at it. So let's see if we can factor anything. And in the numerator, there's a common factor of x cubed. So it's x cubed times x cubed plus a squared y. In the denominator, you can see that all these powers are even. So this is actually going to be the difference of 2 squares. So the difference of 2 squares looks like this. If you have a squared minus b squared, a plus b times a minus b. And here a is going to be x to the third, and b is going to be a squared y. So we can write x to the 6 as x to the third squared, and we can write a to the 4th y squared as a squared y squared. So this is going to be x to the cubed plus a squared y times x to the cubed minus a squared y. And that's what we'll put in the denominator. And then we can cancel. And what we're left with is x to the cubed over x to the cubed minus a squared y. There's our MIT entrance exam. Does it look difficult so far? Would you consider these problems challenging or not? Problem number 5 is a large expression involving a's and b's, a plus b and a minus b. So let's take a look at this one. So we have a division, so we're dividing these two expressions. Let's first write each of them as one fraction. So we need a common denominator, which would be the least common multiple of a minus b and a plus b, and that's a minus b times a plus b. So we'll write these two fractions over that common denominator. So for this, we have to multiply the top and bottom by the same expression, which here is going to be a plus b. So in the denominator, we'll have this. And here in the numerator, we'll have the a plus b times a plus b. So we multiply the top and the bottom by a plus b. And here, we'll multiply the top and the bottom by a minus b. And then we'll do the same thing with this one. So we're dividing it, and it's going to be a similar game. And so it's going to be a plus b times a plus b, a minus b times a plus b. This time it's a minus. So we have a common denominator, so we can write both of these fractions over the same denominator. And just note that a plus b times a plus b is a plus b squared. So we'll just make it a little shorter there. So that's a plus b squared plus a minus b squared all over this common denominator of a minus b times a plus b. And then we're dividing that by, similar thing, a plus b squared minus a minus b squared over common denominator. And it's the same denominator. A plus b, a minus b. So now we're dividing. And we're dividing a fraction by a fraction. You keep the first one, you flip the second one, and you turn it into a multiplication. So it's a plus b squared. So we're going to keep the first one. Over. And now it's times. And we're going to flip it. So it's a plus b, a minus b. So we've just turned it upside down. And it's a plus b squared minus a minus b squared. A lot of a's and b's running around. And now these cancel, fortunately. Same factor in the numerator and the denominator. They will cancel. And it'll take us closer to what we want. And we're left with, in the numerator, a plus b squared plus a minus b squared. So this might be the most challenging one in this whole somewhat surprising exam. And so this is a plus b squared. And now this is just a minus. Let's multiply these out. So a plus b squared. So you're going to get a squared plus 2ab plus b squared. Now we multiply this by itself. A squared minus 2ab plus b squared. Now in the denominator, a squared plus 2ab plus b squared minus, so we get what we had here, except everything gets flipped. So everything gets negated. Minus a squared plus 2ab minus b squared. Now we combine like terms. So we get a squared and a squared is 2a squared. The 2ab and minus 2ab cancel. And b squared and b squared is a 2b squared. So that's all we get in the numerator. In the denominator, the a squares cancel, b squares cancel, and we're left with 4ab. And we're almost done. We can factor out, there's a common factor of 2 in the numerator and the denominator. 2 times 2ab. So they will go, and what we're left with is a squared plus b squared over 2ab. So a lot of algebraic gymnastics there in this MIT exam. And now let's move on to the next one. So the next problem in our 19th century entrance exam is this one. We're being asked to solve for x. It's a linear equation involving x. So let's first clear the denominators by multiplying both sides of the equation by the least common multiple of 2, 8, and 16, which is 16. So we multiply the left by 16. 3x minus 4 over 2 minus 6x minus 5 over 8. And we multiply the right by 16. So we distribute the 16, and we get 16 times 3x minus 4 over 2 minus 16 times 6x minus 5 over 8. And here the 16s cancel. It's a common factor, so it's 3x minus 1. And then 16 divided by 2 is 8. This becomes 8 times 3x minus 4. 16 divided by 8 is 2. This becomes 2 times 6x minus 5. Now we use the distributive law. So 8 times 3x is 24x. 8 times 4 is 32. We have a negative here, so this is negative 2 times 6 is negative 12x. Negative 2 times negative 5 is plus 10. And we have 3x minus 1. And so now let's combine like terms on the left. So 24x minus 12x would give us 12x. And minus 32 plus 10 would give us minus 22. Let's subtract 3x from both sides, and we'll get 9x. And we'll add 22 to both sides, and on the right, we'll get 21. Now finally, we can solve for x by dividing both sides of the equation by 9. We get x is 21 over 9, but 3 goes into both 21 and 9. So we can factor out that common factor, and 21 divided by 3 is 7, and 9 divided by 3 is 3. And that's our answer to that one. Our last question in this exam is they're asking us to solve 2 equations and 2 unknowns. So we have 7x minus 5y is 24, and 4x minus 3y is 11. And we have to find what x and y are. Let me copy the equations down. Kind of put one on top of the other. So 4x minus 3y. We'll use the technique of elimination on these. So let's multiply the first equation by minus 4 and the second equation by 7. And then we'll be able to eliminate x because we'll have a minus 28 plus 28 for the x. So when we do that and we rewrite, so we're multiplying everything left and right by minus 4. So we get negative 28x plus 20y is equal to minus 4 times 24 minus 96. And rewriting the second equation, 7 times everything is 28x minus 21y is equal to 77. Now we can add the 2 equations and we eliminate x. And negative 21 plus 20 is a negative y. And this is going to be equal to a minus 19. So if you simply multiply left and right by negative 1, you'll get y is equal to. So now to find what x is, we can just substitute y in either of these 2 equations. So let's just use this one. And so we'll get 4x. So we're going to plug in 19 for y. Minus 3 times 19 is equal to 11. And then we'll solve this for x. 4x minus 57 is equal to 11. And let's add 57 to both sides. We get 4x is equal to 57 plus 11, 68. X is 68 divided by 4, which is 17. So y is 19 and x is 17. And that's our solution, and that ends our rendition of doing the MIT entrance exam. 19th century. So let me know, guys, did you think they were too easy or were they too hard? My impression is they seem surprisingly easy. Okay, thanks for watching.